Hello, what's going on, guys? Today we're going to continue with Leetcode problems, and this one today is a medium, and I'm doing this one because there's a Leetcode July challenge, and the one today is find the minimum and rotated sorted array number 2. So I figured we'd do this one first. So at first this looks like a really simple problem. Let's read the prompt. It says, suppose an array sorted in ascending order is rotated at some pivot unknown to you beforehand. So 0 through 7 becomes 4, 5, 6, 7, 0, 1, 2. So it gets rotated at some pivot, and we can then see that it is no longer unsorted, but at the pivot here, 0, we're moving this over to the end of the array. So they want you to find the smallest element in this array, right? So, and you may assume that no duplicates exist. I think the difference between this and number 2 is that there are duplicates in number 2. But for now, it looks really straightforward, right? So if you have 3, 4, 5, 1, 2, really all you would do to solve this is just go through each one and see, find an element that is less than the previous one, right? Because it's supposed to be sorted, so obviously you found the pivot if 1 is less than 5, because anything after a certain number is not supposed to be less than it if it's a sorted array, right? So that's a really simple solution. That's not the optimal solution. They don't tell you what kind of time complexity they want here. But let's just do that one first, and then we'll get into something that'll run a little better. So you can just loop through it. So you just do loop through the range of the length of the nums. And then you can just have a check here that says, like, if the nums I is less than the one, if nums of I, so for example, 3, 4, 5 is less than the one after it. So right here it's basically if I is less than the one before it, which it should never be, right? Because 1 should never be less than 5. If it's supposed to be a sorted array, we can then just return that. So let's run this. Okay, why is this taking so long? Okay, that seems to work. Let's submit this. And this is actually not well because there's an edge case that we didn't account for. So if the array only has one item, we can do something like if len nums, let's just do something really naive here and go less than 2. We can just return the first element in there. So this should run now. Nums, submit that. Okay, this ran. But, you know, this is probably not going to be acceptable, right, in like a, you know, in an interview or whatever, right? This is you have to loop through every item, which means you have to hit everyone. So we're on order of n here. So what's something we can do better? Let's delete this. It's a perfectly acceptable solution, I think, but probably not optimal. So let's look at the prompt again. This says sorted array. So when I think sorted array, that's telling me that we can maybe do some sort of something with pointers, something in the binary search realm. So let's go ahead and get that started. So we'll say create couple pointers to the indexes, just a regular binary search here, and we'll say the left is equals to the 0 element and the right pointer is equals to the last index. Okay, now what we're going to do here basically is a bit of a modified binary search where we're basically going to check to see if, well, we're going to make sure that the bounds haven't met yet. So while left is less than right or something like that, we're going to find a midpoint, and then we're going to check if, maybe I can zoom in on this a bit better. There we go. We're going to check if the middle point that we found, which in this case, for example, would be 7, is greater than the number on the right, which it shouldn't be, because if it were sorted, 7 would never, the number in the middle of the array would never be bigger than the one on the right. It would be the opposite. The one on the right is the largest element in a sorted array. So that'll basically tell us we then have to start looking on that side of the array, because that's where our pivot begins, and we can move our pointers accordingly. So that's how we're going to do this. Let's go ahead and set up our little loop here. So while left is less than right, we'll find a middle. So we'll just call it middle point is going to be equals. That's a very long variable name, but whatever. And we'll just find the mid here in a something you should maybe remember to finding middle. You can also do like math floor left plus right divided by 2 or something like that. But this will work. And then what we're going to check is if the one number in the middle is greater than the one on the right, which it shouldn't be, right? At that point, we can move our left pointer up to where the middle used to be and add 1 to it. So it'll then become, it'll go from left, we'll move that left one up to here because in this case, our middle 7 is greater than 2, which it shouldn't be, so we'll move our left pointer up to here. So we'll go left equals middle point plus 1, and then we'll do the same thing for the right. So basically the opposite of this. We'll say right equals middle point minus 1. Okay, now what we can then do is now here we can actually check if the middle is less than the one before it, because that'll basically tell us we're done. So if the middle becomes like here, if this is less than the one before it, we know that we found our result. So if 0 is less than 1, we now know that that's where the array was pivoted, and we can return that. So let's do that. Something like if nums middle point is less than nums middle point minus 1, we can then just return nums middle point. And let's run this. Okay, that works. Output none. Oh, I see. Okay, so that test case is going to fail because we're actually going to want to return the left. So if this doesn't occur, we're going to want to do something like nums left, because now the left pointer is where it's supposed to be. So let's try that. Okay, cool. So we did a couple solutions for this. The first one was, let me go back here, copy this, and I'll go back a whole bunch. The first one was just a really simple linear solution where we look over every element and and make sure that, let's run this, make sure that the number is greater than the one before it, so as to check that it's a sorted array. But again, this one's really slow. And the second solution that we did was something a little differently with a binary search. And again, if you see some sort of like, sorted array, maybe, I mean, it's not like necessarily a rule, but maybe something that can give you a hint. If they don't tell you that they want you to do this in logarithmic time, maybe you can start getting hints from looking at the wording in the problem. So important to read the problem. But anyway, hope that was helpful, and I'll see you guys in the next one. Thanks.